Hello, and thank you for joining today's Tech Talk. My name is Emma McGrattan, and I'm Senior Vice President of Engineering at Actian, and I have responsibility for Actian's analytics product portfolio. The subject of today's Tech Talk is Actian Vector, and we're going to take a deep dive into the technology behind Vector and what provides it with the performance characteristics that it serves. Actian Vector is actually a family of products, and they can run on anything from a Windows laptop right the way through to the largest cluster. There's three things that we focus on for developing the Actian Vector technology. The first is performance, and that's what we're known for, right? There's nothing in the world that performs as fast as Vector does, and we've proven it time and again through benchmarks. When we look at performance, we look at everything from maximizing the capability of a CPU, making sure that we get every last clock cycle out of the CPU. Looking at storage, right? Storage is a big contributor to performance characteristics when you're dealing with large volumes of data. So making sure that we've optimized our use of storage. And then memory, right? So that's the third component here, making sure that we're using memory efficiently and not just RAM, right? Which is where people typically think of memory, but actually looking onto the CPU and the fact that it has a number of caches built into the CPU that provide us with a few meg of storage that we can use. So more about that later. We've also built the product so that it fits into the existing BI and analytics ecosystem. So what that means is that we focused on the SQL standard, and in fact, we have a representative on the SQL language body. And what we want to be able to do is, as people have existing integration workloads, right? They've built out their ETL workloads, they've built out their BI and analytics workloads, and we want to fit in the middle there, right? So to be able to support all of the integration tools that are most commonly found out there, and it might be Talent for ETL, it may be Informatica, whatever it is, we will work with that environment. And then to be able to serve the needs of tools like Tableau and Power BI and Click. So being standards-based means that it's really easy to slot into that ecosystem and that end customers don't have to rework stuff that's already been done. They can just point those workloads at Vector and it'll handle it better than they've ever seen before. We also have been very open in making sure that we support open standards and open source. So ODBC, JDBC.net are the industry standards that you'll see being used for accessing data. We also, on the open source side of things, we've built out a solution in Hadoop that leverages Spark and that enables us to integrate with that whole open source ecosystem that's out there. The third thing that we focus on is the fact that a lot of our products are deployed in mission critical environments. It's 24/7 availability required of us. It's the ultimate in protecting the data, securing the environment. If a customer environment goes down, they want the reassurance that we will get them back up and running as quickly as we possibly can to minimize that outage, and then we'll do root cause analysis. So we have an amazing support team, and they're here to support all of your efforts. That we look forward to collaborating with you. So I mentioned that Actian Vector is a family. There are three members essentially to the family. So the first is Vector, and Vector is a single node analytics database measured as the fastest in the world. It runs on both Windows and Linux. Typically with Linux, we'll see about a 20% performance advantage over Windows, but we do have customers that run both and some pretty large deployments on Windows too. One of the problems with the initial Vector implementation on Linux was that a typical Linux server is limited to about 10 terabytes of data. The CPU power in the server, together with the memory and disk available, typically we put that rule of thumb on it up to about 10 terabytes. So when data sets scale beyond 10 terabytes, we needed a solution that could scale with our customers. And that's when we came up with VectorH. So VectorH is a identical product to Actian Vector, except the I/O is optimized for HDFS. And HDFS is the distributed file system that sits under Hadoop. It's a file system that is designed for commodity disks, and it assumes because they're commodity disks that they're going to fail more frequently than more expensive disks. So it's got redundancy and things built into it that we can leverage with Actian Vector to provide the same type of performance that we're known for on Linux and Windows, but on a Hadoop footprint. It's quite amazing. It scales linearly. So let's say you were getting 1 million transactions an hour on your single server, and you scale that to 10 nodes of identically configured hardware, you can expect that you would get 10 times that throughput or 10 million transactions in an hour. The third product that's part of the Vector family is Actian X. And this was a product we brought to market last year. It combines the Ingress OLTP database, which is actually how I started at Actian, with the X100 engine, the engine that makes the analytics solution so fast. And in a single footprint, we've got the ability to not only do high-speed transactional data, but then to analyze the data that's generated from those transactions. So this is a great upgrade path. It's a natural upgrade path for our existing Ingress accounts, but it's also great for new development, right? So if you come across a greenfield opportunity where you know that it's a mostly transactional app, but high performance reporting, business intelligence and analytics is going to be required, then this is a solution that you should definitely look at. So on the previous slide, the X100 engine was common to all three products. What we're going to do now is to take a look under the hood at the X100 engine. So what you'll see on the slide right now are 6 different things that make Vector X100 engine unique. It's the combination of all 6 that make it unique. You will find some of these capabilities in our competitor products, but not all of them, and not designed in from the ground up. I will be going into greater detail on each of these topics on subsequent slides, but just so that you kind of get this high-level view, the first is vectorized processing, and that's where the name vector comes from. You can think of a vector as an array of data, and what we're able to do with vector is, instead of operating on single records at a time, we can operate on arrays of data at a time. And vectorization is something that's available in commodity CPUs, whether they're from Intel or AMD. It doesn't require specialist and very expensive hardware. This will run, as I mentioned earlier, on your laptop, and it will really impress you. The second thing is that we developed Vector to take advantage of the fact that modern CPUs have an on-chip cache of several megabytes, right? So they have multiple caches, different layers of caching. And our thought is that if we use the chip cache for staging data, then as we need to access that data, it's really nearby, right? And it's a couple of clock cycles to take it from where it resides in the chip cache into the execution registers. So that's really clever and works really well for us. The third point on here is that you'll see we call ourselves second generation columnar. Now, columnar storage makes sense for analytics solutions because the typical access method for analysis is columns at a time, right? So let's say you're dealing with, get me the average price paid, right? You don't want to read the entire record for the purchase. What you want to get to is just the price column in that data record. So what we do with Vector is we store the data as columns. We actually store it as vectors. I mentioned the vector in point 1, mini arrays. These are compressed vectors as they're stored on disk. Now, the reason we call ourselves second generation columnar is that we've actually cracked the code on how to do updates in a column store. That's a real challenge for many column stores. Vector's cracked that challenge. The fourth thing on here is compression, smart compression. And we call it smart because based upon the type of data that we're compressing, we'll choose the most appropriate compression algorithm. User doesn't need to know anything about compression or the algorithms available to us. The fifth thing on here is storage indexes. So essentially what we wanted to do was to make Vector as simple as possible. And one way of achieving that was that we automatically build indexes on the data as it's been loaded into Vector. We keep track for each data block that we're writing to disk. We keep track of the minimum and the maximum value within that data block. So then when we're solving a query, we're able to identify which of the blocks that are going to participate in solving the query and which are the ones that won't, right? So we don't obviously bother reading the blocks that won't participate in solving the query. So it leads to really efficient I/O patterns for Vector. And then the sixth thing on here is multi-core parallelism. We've designed Vector for the fact that many servers today ship with over 100 cores in it, and in fact some have over 200 cores within them. What we want to be able to do is to maximize our use of all of those cores, right? So that was important for us and one of the considerations in designing Vector. So now what I'm going to do is look in greater detail at each of the features. So let's start with vectorized processing. So many of our competitors, and if you think of our competition, it may be SQL Server, maybe Oracle, could be Teradata, Exadata, and then many of the Hadoop solutions we also compete with. But it's typically, well-known enterprise scale analytics solutions. Some of them will be working as operational data stores. Some of them will be working as enterprise data warehouses, but that's typically where Vector's competing. And for many of those products, they date back to a time when vector processing wasn't available in commodity hardware. And to take advantage of vector processing, they would have to essentially throw away the entire code line and start over. And of course, they were unwilling to do that. So this is a benefit that we were able to take advantage of, and some modern solutions that were built within the last 10 years also take advantage of vectorized processing. But when I talked earlier about a vector being an array, I think what we've attempted to do here on the right-hand side of the screen is to kind of illustrate what that means. So in the first of the two diagrams here, you'll see traditional scalar processing. And what we're doing here is we're adding two values together, and we're taking value A from a column A and value B from column B, and we're adding those together. So what you'll see is with a traditional approach, you go record at a time, and you do that calculation all the way down to n plus m, right? If we look on the right-hand side with vector processing, we actually read an array of values from column A. So it's up to typically about 1,000 values in an array. We then read an array of values from column B, and again, about 1,000 values, and then we add them together in a single operation, right? So instead of going record at a time doing this calculation, we're able to, in a single operation, add those 1,000 values together. Now, this is a very simple example, but you can imagine if you're trying to calculate the average price paid for something, or the average salary for all of the people filing tax returns within the United States. These can be very large calculations, and we're able to do it much more efficiently than anybody else in the market. The next point on here is exploiting chip cache. So this is really important from a performance perspective. So basically, if you look at a modern CPU, you'll find up to about 8 megs of memory in the level 1 and level 2 caches. And Vector is able to use that for storing data before it moves it into the execution registers. On the graph here, what I'm trying to illustrate is how things have moved on in terms of the performance that one can expect and the throughput that one can expect of disk versus RAM versus chip. So on the y-axis of our graphs here, we've got the number of cycles, the number of clock cycles it's going to take to process data coming from those three sources. So for disk, you're talking about thousands, even potentially millions of clock cycles to get the data that you want to access from disk. In RAM, you're talking about 150 to 250 clock cycles, whereas when the data is in the chip cache, you're talking about maybe a couple of clock cycles, most about 20. So that's important, right? And then if we look at the x-axis, what we can look at is the amount of data that can be processed in a second. So for disk, I mean, it really varies, right, depending on the types of disk you're using, but anything from 40 megs a second to a gig per second. For RAM, it's about 20 to 50 gigs per second. In chip, it's about 100 to 200 gigs per second. So almost an order of magnitude improvement over RAM. So that's why it's really important to us to be able to leverage that in-chip cache as a staging area for data. So the data within Vector lives as a compressed vector its entire life until it gets to the chip cache, and that's where it's decompressed. So that is another big part in why we're as fast as we are. Now let's take a closer look at what we mean by second generation column store. Many analytics solutions that were built specifically for analytics store data in a columnar orientation. And the reason for that is that the access patterns tend to be accessing columns of data as opposed to rows. If you look to the right-hand side of the screen here, you'll see an example of what I mean. So in this case, we're dealing with a bank account, and we've got the account number, we've got the customer's names, we've got their balance, we've got their gender, the street name, the suburb or town they live in, and their postcode. Now, in a traditional database, an OLTP database designed for transactions, the data is stored as rows on disk. Now, if what we're trying to do in the query that we're running is to find the female customer with the highest bank balance, right? We're in the row orientation. We have to read the entire row so that we can identify the customer, the bank balance, and their gender, right? So that is it's reading a lot of data that you actually aren't going to need to access to figure out the result. If we do the same thing, but in a database that's storing the data as columns, we'll read the account detail, so get that account number, we'll read the balance, and we'll read the gender columns. So this greatly reduces the amount of data. If you look at the table, it's 3 out of the 8 columns being read, right? So that's pretty good and very efficient. Obviously, when we're reading less data, there's less I/O going on. It's consuming less space in the memory caches that we've allocated for the database, and it speeds up processing. Now, getting back to this whole idea of a second generation column store. First generation column stores you can think of as products like Sybase IQ and Vertica. They store data as columns as well, but what they do that's very different to what Vector does is they read the columns from disk and then they reconstitute the data as rows. Whereas with Vector, we treat the data as columns and it lives as columns within the system. Now, we can regenerate rows if that's what's required to serve up to the BI analytics tools as the results of a query, but we're not dealing with data as rows because that's just hugely inefficient. The next characteristic that leads to our claim of being second generation is how we handle updates within the system. So Vector includes a capability that's referred to as positional delta trees. And these positional delta trees enable us to support real-time updates. And this is something that we can do on Linux and Windows, as you'd expect, but also on Hadoop, where the file system was designed for data to be written once and read ever after, with new data coming in as kind of an append to the existing data set. With Vector, we're actually able to support in real time inserts, updates, and deletes. And we do it in a way that's ACID, in that we can support transactions, and either that entire body of work is committed or none of it is, and we can roll back transactions. And it's a capability that's unique to Vector, and we do it in a way that doesn't impact the performance of the running system. Now, the name positional delta tree comes from the fact that it's a tree structure and it keeps track of the position of the delta or the change, right? So that's where the name comes from. It's a tree structure that keeps track of the position of the delta. The tree structure is only ever 3 levels deep, so it's really easy to traverse it. It makes it very quick for traversing it, and as data gets updated, the performance of Vector, you'd hardly notice the difference. In fact, in tests that we've done where we measure it, it really is incredible how we've been able to minimize the overhead of the updates that are coming into the system in real time as it's being queried. So a great capability that differentiates us on Linux and Windows, but something people don't even dream of on Hadoop. So that's a real differentiator for Vector on Hadoop. Now moving on to data compression. Compressing the footprint of data when you're dealing with massive data volumes is really important. It's important from a storage perspective, but much more important from a performance perspective, and being able to move the data through the system as quickly as possible. One of the many benefits of using a columnar orientation of data in an analytics database is that when you're storing the data as columns and you're treating it as columns, you're able to apply compression algorithms to blocks of data, knowing that all of the data within that block is of the same data type. When you're dealing with row data, you can imagine that you'll have some numeric data, you'll have dates, you'll have character data, you'll have a wide mix of data, and coming up with one compression algorithm that will work efficiently across all of the data within a row is difficult. Whereas with columns, coming up with a compression algorithm that's going to work for a data type, for instance, decimal data compresses very differently to character data. And even with character data, you've got, depending upon the data itself, you've got a wide variety of algorithms that you can choose from. So that is something that we focus on in choosing compression algorithms, is the efficiency at which we can decompress the data into the chip cache. That's much more important to us than minimizing our footprint on disk. And the reason for that is that we're focused with Vector on performance. Disks are relatively inexpensive, and the compression ratio that we get with Vector is typically about 6:1. It might be as low as 4:1 because it's very much data dependent, but we get a good compression ratio and an outstanding performing and efficient algorithms that we use. We have a variety of algorithms, and they depend upon the data that's being compressed. And we'll choose the right algorithm based upon an individual block of data. In designing Vector, we wanted to make sure that the performance was almost guaranteed. Now, we've done as much as we can in designing a execution engine that runs really fast, but we were a little concerned that the database administrator or the person designing the database schema may not choose the right storage indexing for the query paths that we were going to encounter. So we decided that by default, Vector would index the data. So as data is being written to disk, we automatically create an index on that data. We call it a min-max index. And essentially, it's a summary index where we have the minimum and maximum value for each column. And what that allows us to do is, as we're identifying the blocks that are going to participate in solving a query, we can really quickly get to the ones that will be used and ignore anything that will not be participating in solving that query. So let's say I'm looking for the man who spends the most on sports tickets that's living in zip code 11749, right? I don't need to read any data for anybody who's outside of the 11749 zip code. And I can get to that really easily using the storage indexes. So that is something that is built in by default. It's really simple. If people are moving from other technologies to Vector, we typically will recommend that they discard all of their indexes and use the default storage indexes. And if there is a performance issue that we believe could be addressed by adding an index, then and only then will we create indexes on vector tables. But this works incredibly well, and it is part of the reason why we're as fast as we are. And then the last point on here in the contributors towards the performance profiles that Vector can demonstrate is multi-core parallelism. So what we want to do within Vector is parallelize the execution of a query as much as makes sense, right? So you get to a point where you have diminishing returns, where it may take more work to parallelize the query and bring the results back together again than the benefit that you would get from that parallelization. But we've factored all of those smarts into the product. So we'll break a job down into multiple parallel paths. We'll have those execute on the CPUs, and then we'll pull those results back together again. And this allows us to perform as well as we do. And we can look at performance profiles, and we can generate profiles for all of the queries that are running in the system. And what you'll see on the bottom of the screen here is a performance profile where we've got a couple of hotspots. And a hotspot is indicated by pink, and the darker the shade of pink, the more attention you should focus on that, because it looks like there's an area in which we could improve performance, and we would then dig deeper into what's going on in that particular case. So that's the X100 engine. And as I mentioned earlier on, the X100 engine is what causes Vector to perform as well as it does. A X100, the name comes from the fact that it was designed to be 100 times faster than anything in the market, and we were able to prove that. Now, the X100 engine is common to Vector, VectorH, and Actian X. What we're going to do now is to dig a little deeper into Actian Vector and Hadoop. We now call this product VectorH, and we're kind of de-emphasizing Hadoop because we use it only for HDFS and Yarn, and we call it VectorH just as shorthand. So what you're seeing on the screen right now is how we position VectorH. And in very simple terms, on the y-axis here, we have enterprise readiness, right? Whether or not this is ready to power the biggest enterprises in the world. And on the x-axis, we have level of innovation. So what we've done with Vector is we've provided all of the capabilities that one expects to find in the likes of IBM's Netezza, Vertica, Teradata, Oracle Exadata, and so on. So all of those enterprise capabilities, expectations that were set by those more traditional enterprise data warehousing products are delivered in VectorH. But we've done it on a platform of innovation where we can't be matched, right? So we've out-innovated the likes of Hive and Cloudera and Apache's Drill. We have a product that's really cutting edge, that's really differentiated, but that's designed to fit into today's business. So what it can do is replace the technologies that are in that traditional enterprise data warehouse bubble, replace those, but set customers up with a futuristic and future-proof platform that not only enables them to run the Hadoop workloads of today, but that we're confident will support them in years to come in the applications that they develop for analytics. So it's really performant. It'll outperform anything in the market. If you look to the the bottom right hand corner of the slide, what you'll see is the results of a benchmark that we ran, where we took a set of queries and ran them against Vector, Spark SQL, Impala, and Hive. And what you see represented in the graph here is that for Hive, it took over 2 hours to run those queries. For Impala, it took almost 2 hours. For Spark SQL, it was over an hour. And for VectorH, it was under a minute. So blindingly fast. It supports standard SQL. So any tool that's out there today that's SQL based that connects to a database through ODBC, JDBC, or .NET will just work with Vector, and we guarantee that. As I mentioned already in describing the positional delta trees, it supports inserts, updates, and deletes. And anybody familiar with Hadoop knows that Hadoop really struggles with updating data. It really wasn't designed for that use case, but that's something that our positional delta tree sets us up for in Hadoop. And we can take a customer workload where they may, for instance, be feeding transactions from their enterprise systems. So it may be that they're running Oracle eBusiness Suite or SAP, and they can feed those transactions at the rate at which the transactions are being generated by the business into VectorH, and they can analyze those in real time. And by real time, we mean that once we commit a transaction, any subsequent transactions will see the results of that. Some customers have expectations now set of real time to be within 15 minutes. It's ridiculous as far as I'm concerned, but it's something we're really proud to say that we're completely ACID compliant. When we commit a transaction, all subsequent transactions see the result of that. We also have the ability to roll back transactions. So let's say you make a mistake and you want to undo it. That's something that we can support. Or let's say you're moving money between bank accounts and your money leaves one bank but the other account can't accept it. You can unroll the entire transaction and make sure that your bank accounts are safe. So ACID compliance is important for enterprise applications and something that Vector supports. I'm going to talk in greater detail about security later on because it's another area in which we're differentiated. So it's performance, it's the ability to support updates, it's enterprise readiness, and it's the security features that we provide. We conservatively believe that we're about 18 to 24 months ahead of the competition, but being frank, some of them will never catch us. So on this slide, what I've attempted to do is to show you how we would see Vector fitting in the enterprise. So on the left-hand side, we've got a multitude of data sources, right? So it might be some local databases. It could be some streaming data coming in from IoT applications or a enterprise service bus. It could be data coming in from remote data centers, or it could be cloud-based applications, right? So it might be Salesforce, it might be NetSuite, it might be Amazon S3. We can take that data from any of those sources using a variety of methods. So it might be that we use traditional ETL tools like Talent or Informatica. It might be that we've suggested the use of Dataflow, which is an incredible piece of technology that you should learn more about. And we also have an Actian technology called Data Connect, and that's another way of connecting data like Salesforce and bringing it into Vector. And then from the open source side of things, we also have a Spark connector and a Spark loader. So if the customer is really heavy on Spark for ETL, that is something that we support and encourage as well. So those are the various methods. We also support replication and change data capture and other ways of getting the data in here. There are some customers that don't want to move data into Vector, that they would much rather leave their data where it is and to be able to access that data from Vector. And that is something that we can provide support for as well. So in the middle of the diagram, well, slightly to the right, you see Actian Vector sitting on HDFS and with Spark integration. And above that, you'll see that there's a variety of data sources that we can get to, including Hive, Postgres, Amazon S3. It doesn't really matter. There's a whole variety of them, and we support all of them. And then to the right-hand side, what you'll see is the user base that we support. So we have seen in a lot of organizations that the business users are given access to tools like Tableau and Click and Power BI and Business Objects, and they want to be able to query that data, issue their own ad hoc queries against it, and that's something Vector supports. So powering that business user and giving them the ability to run what-if scenarios and opening that up to ad hoc querying is a amazing capability and something that Vector provides. And then what you'll see on the bottom of that is the data scientists and the data engineers who want to access the data from a different perspective, right? Maybe they're using AI, ML, maybe they want to write applications using Spark SQL, Scala, or Python. Those tool sets are all supported as well. So it's bringing data in or ingesting data from any data source, accessing data where it resides anywhere, and then serving the needs of any user, right? So it's the business user, it's the data scientist, and it's the data engineer. Here what you'll see is the front page of some amazing benchmark reports that we ran earlier this year. On the bottom of the screen, you'll see a link through to where you can access these benchmark reports. But essentially what we did was we hired an outside consulting group to run the UC Berkeley AmpLab Big Data Benchmark. And they ran that benchmark at 1 terabyte, 5 terabyte, and 10 terabyte scale against Vector, Microsoft SQL Server, Amazon Redshift, Snowflake, and Cloudera's Impala. And what you'll see on the screen here is that when we compared our performance against SQL Server, we were 10 times faster. For Redshift, we were 14 times faster. Snowflake were 20 times faster. And for Impala, we're 100 times faster. One of the things that you don't see, because these are just the covers of the reports, is that as the query complexity grew, our performance differential grew, and as the number of concurrent users in the system grew, our advantage over the competition grew as well. So as data volumes grow, as data query complexity grows, and as the number of users grow, our lead over the competition grows as well. So an amazing space to be in. This slide is a little difficult to read, so let me explain it to you. This slide was taken from a paper that we delivered at SIGMOD, which is a database industry conference. A lot of industry experts and academics in the world of database attend this conference every year. In 2016, the conference was held in San Francisco, and we submitted a paper comparing the performance of Vector with the other SQL and Hadoop solutions. For this particular conference, all papers have to go through peer review, and this was reviewed and accepted and went down very well. What we're showing here is an extract taken from that paper, and the paper essentially to measure performance used a TPC-H benchmark, and we ran that TPC-H benchmark against Vector, Hawk, Spark SQL, Impala, and Hive. And in running the benchmark, we came out significantly faster. So if you look to the table below the graph in here, what you'll see is, let's just look at the first query. For Vector, this query completed in 1.34 seconds. For Impala, it was 585 seconds, and for Hive, it was 490 seconds. Trying to convey this information in a graph was difficult, so we decided that we would in the graph express how many times faster Vector was than the competition. So that's what you're looking at in the graph. And we had to express that on a logarithmic scale because we were just so much faster, right? So it's, up to 10 times faster, up to 100 times faster, up to 1,000 times faster. And so significantly faster than the competition. The TPC-H benchmark also has what's referred to as refresh streams as part of it. And the paradigm is simulating an enterprise data warehouse where you would age out 1 day's worth of data and bring in a news day's worth of data, right? So typically for this particular use case, I think we were looking at 5 years worth of data, and we aged out the oldest day and brought in a new day. Hive was the only other product that we tested that was able to support that workload. And in Hive, once we aged out the 1 day and brought in a new day, the performance dropped quite considerably. So if you see the Hive query for query 1, previously was at 490 seconds, as I said, now that goes to 608 seconds. And when we measure this difference across all 22 queries that are in the query set, the performance for Hive is 138% of what it was previously. So it's dropped by almost 40%. And that's just updating 1/1000th of the data. Can you imagine if you're updating, larger volumes than that? So now just to talk about, some of the other things that make Vector so special. I kind of group these into 3 very large buckets. The first is enterprise grade, right? So what's important to us is to be able to support existing workloads. So whether those are integration workloads, BI and visualization tool workloads, we find that if we focus on supporting the standard, then those workloads will just work with Vector. And for many cases, we've gone to customers, installed Vector, loaded their data, and then we will take their existing Tableau or Power BI reports, point those reports and dashboards at Vector, and it will just work. So it really can be that simple if they haven't done anything particularly complicated. As I've mentioned a couple of times, we're ACID compliant, and what that means is that we bring transactional integrity to Hadoop. And as you say, you commit a body of work, that body of work is reflected in all subsequent transactions. We also use what's called a write-ahead log file, so that should the system fail for whatever reason, before the changes that we have seen in the system get committed to disk, they'll be in that write-ahead log file, and when you restart the failed system, it replays that log file, and you will never lose a transaction. We guarantee that transaction integrity. The update capability, I can't stress enough. The biggest disappointment to me is that people do not expect this on Hadoop, so people aren't looking for us because they don't know or don't imagine that anybody can provide this capability. It's unique to us, and I would be really grateful if you could get the word out about that. And then the last thing on the enterprise grade category is our DBMS security, and that's important enough that I actually have a slide where I call that out separately. Performance is what we're maniacal about. So it's executing queries really quickly, supporting a high concurrency, so a large number of users hitting the system at the same time, which is what concurrency is all about. Being able to figure out the best query execution plan for a query. That's really important, right? As you execute queries on the system, you want that to be the best possible plan. And typically with a query execution plan, you look at the query, you have an understanding as to the characteristics of the data, and you make sure that you come up with a method of executing that query that is the most efficient given the data characteristics that you're dealing with. And the last thing under performance is our use of Yarn. We have a unique capability with Yarn where we're able to grow and shrink the resource pool allocated to Vector. Yarn was actually designed for short-running jobs. Vector database, you anticipate starting it when you install it and never having to shut it down unless you want to perform some kind of maintenance or an upgrade, for instance, that would require that you take the system down. What we're able to do with Yarn is actually to identify the minimum resource pool that Vector can run within, the optimal resource pool that you want Vector to run in, and we can shrink and grow that pool based upon other activities in the system. So for instance, at the end of quarter or end of year, you may want to allocate more resources to your ETL jobs because it may be that those are the most important jobs to you at that moment in time. So you can scale back the resources allocated to Vector, reassign those resources to ETL, and then when you're done with all that ETL processing, you can have Vector go back to the previous allocation of resources without having to stop and restart the system. So that's huge, and that's something that's unique to us, a really smart use of Yarn for that. Our Yarn integration also gives us the ability to operate in a mixed workload cluster. So we don't require a dedicated cluster for Vector. We do recommend that we put Vector on nodes that are dedicated to Vector because it's a beast when it comes to CPU consumption, memory consumption. But if you don't have the luxury of being able to define a set of nodes that are dedicated to Vector, and we can, within the context of Yarn, constrain Vector to a given set of resources. And then the last bucket on here being open. We are cloud agnostic, which means that we're adopting support for all of the cloud vendors. We focused on the big two, right? Azure and also AWS. But there's nothing to prevent us implementing our solutions on Google Cloud and Alibaba, IBM Cloud, Oracle, whoever it may be. But we focus on the big two to begin with. We're also Hadoop distribution agnostic, recognizing that people will settle on a Hadoop provider dependent on whether or not they really like the services provided by a given vendor or the customizations that are part of that Hadoop offering. So we support Hortonworks, Cloudera, and MapR. Also standard Apache Hadoop, if that's your customer's choice or your choice. We've designed it to be an open, collaborative architecture, and what I mean by that is that Hadoop is an ecosystem, and where there's a lot of really cool things going on, and we wanted to be able to be part of that ecosystem, so we've designed for that. Now, I mentioned security was something that was important to us, so just to provide you with a little more detail on that. First is user authentication. And what this means is that we want to be able to confirm that the user is who they say they are. Now, typically, people will use the operating system for that, right? So you can say, I trust the operating system to authenticate that the username password combination that's coming in is in fact correct, and we can do that. But we can also use any pluggable authentication mechanism. So it may be that you're using Active Directory, you may be using Kerberos. We will be able to integrate with all of those, and Vector actually ships with a security guide. So if you wanted more details on how to do that, that's something that's pretty well documented. The next thing that's listed on here is discretionary access control. So this gives us the ability to decide which users or groups of users or which roles within the organization can access what within the database. So let's say I'm a manager of a large team at Actian. I need to be able to access my team's personnel information. It may be that the HR department doesn't allow me to make changes to that, so I could have read-only access to that data, and it might be that HR is given read and write access. I will be excluded from seeing the personnel information from anybody else within the organization, and discretionary access control enables us to limit the ability to view data within the database. So that's hugely important, right? We will often find that customers want to limit down to the user level who can access what data, and who can delete data, who can read data, who can write it, and so on. The third thing on here is role separation, and this is something that we find in very large organizations where they want to have a database administrator that can administer the environment, but that doesn't have access to the data within it. So typically a database administrator is given godly powers. They have access to everything within the system. We often find that customers have data that they want to secure, so it may be that it's personnel records, and they want to make sure that the database administrator can't actually see what the security administrator got in terms of a bonus this year, something like that. So role separation allows us to restrict the database administrator's access to sensitive data. The fourth thing on here, security auditing and security alarms. Security auditing allows you to audit everything that's happening within the system. And there's various levels of auditing that you can do. Obviously, if you're keeping track of everything that's happening in the system, there's an overhead associated with that. So for some customers, they enable a kind of a lightweight auditing. And you can audit activities, whether they're successful or not. You can say, I don't care if a query failed, I still want to know that somebody issued that query. We also have the ability to set up security alarms, and where this is used is highly sensitive deployments. So let's say it's a hospital, and the hospital has a celebrity patient, and somebody on the janitorial staff wants to see why is that patient in the hospital and what's the latest with them. Our discretionary access control would keep the janitorial staff out of the patient record, but the fact that they attempted to access this could trigger an alarm, because maybe you want to look at, what else is that person up to, but they shouldn't be, and then you can shut that down. So security alarms we can trigger. You can have an email or a text alert go out, that's somebody's doing something within the system that they shouldn't, and that'll allow you to take action. The fifth thing that's listed on here is encryption, and this can be really important, right? For sensitive deployments where you've got, maybe it's financial data, maybe it's personal PII data, which is now subject to GDPR, or maybe it's a sensitive patient information. We do find that customers want to encrypt data that's stored in the system, so what we call data at rest. We can encrypt that data at the column level. So let's say you have a table that's your bank account information and everything associated with that. It may be that it's just the social security number column that you want to encrypt, and Vector provides the ability to do that. So to provide encryption at the column level, when you create that table, you would say which columns within the table you want to encrypt, and that's something that we will take care of. We often find that people want to encrypt data as it moves between the database and the application that's accessing the database. So an example might be if you're on your iPad and you're running, a Tableau dashboard and you're sitting in an airport and you're not sure how secure the wireless network is, right? You may well want to secure that data on every part of its journey until it gets to your iPad where it's decrypted and displayed on the screen. And that's something that we support. That's called data in motion encryption. And for that, we use 256-bit AES encryption. We have encountered in Hadoop, because people are not sure about security when it comes to Hadoop, that they may encrypt the entire file system, and Vector can do that seamlessly. You can just install Vector on an encrypted file system, and we've no problem with that. The other approach we've seen taken with Hadoop is that they have encrypted zones within HDFS, and again, that's something that the Vector can provide support for. So great security features. We also very recently, and I guess I didn't update the slide, added what's called a data masking. And what data masking allows you to do is to decide for sensitive data what an unauthorized user can see. So a great example of that is credit card information. So typically when you get your credit card receipt, it will show you only the last 4 digits of your credit card number. Everything else is X'd out up to that point. And with data masking in Vector, you can decide that for certain classes of users that they should only see the masked data. So that example, they would see just the last 4 digits of Social Security number, and then authorized users could see the entire number. So maybe to process and validate the transaction, they'd need to see the entire number. So that's another great capability. And as we deploy Vector in scenarios where GDPR compliance is important, we are getting questions about support for data masking. So I've mentioned a number of times that we have a large partner ecosystem where there's tools vendors that we need to work with. On the left hand side of the screen here, you'll see a subset of the data integration partners. We do have Actian on here because we've got the Actian Data Flow and Actian Data Connect technologies that are great data integration capabilities that provide support for Vector. On the right hand side of the screen, we've got our business intelligence and analytics partners. A lot of visualization, dashboarding, and reporting tools on here. We've got great relationships with many of these folks. Click, Tableau, Microsoft. We see a lot of Microsoft Power BI. And increasingly what we're seeing, and I suspect you're seeing it too, is that in organizations, they're giving the end users the choice of which tool is best for the job. So it's no longer a case where we would go into an account and they'd be like, oh, and all of our users are using Tableau, right? They'll say, oh, they've got some Tableau, some Click, some Power BI, and some Jaspersoft. So it was important to us to be able to support all of those. So the slide limited the number of partner logos I could put on here, but if you have questions about specific partnerships or tooling, do reach out. It's the same as on the integration side. It may be that they're not there because they don't fit, or it may be that we haven't certified them and it's something that we should do, and we will do that with your help. And then in the center here, ActionX, Vector, and Vector in Hadoop all support the same, pretty much the same set of tools, and all support the latest versions of JDBC and ODBC. So if you come across a tool that's JDBC or ODBC compliant, you should be able to just point that tool at Vector. So that's it. It was a whirlwind tour of everything to do with Vector and Vector in Hadoop. I do hope you learned a lot. There is a lot of really detailed and great information out there. So thanks for your time and your attention. At this point, we'll turn it over to questions.